to give everyone like an update on what's going on with the Ledger generic app and the verifiable metadata effort. My name is Juan, and obviously this work has not been only work done by Zondax, but it has been in collaboration with Parity and Alcymologist. So, I mean, how we got here, like back in sub0 2023, we had like a demo and there were like some updates, but since then there have been a lot of progress, but obviously there has been also some kind of like blockers along the way that we didn't expect that to happen. And the idea was to kind of like catch up with the community and give you an update on where things are, what are the blockers, what are the efforts, and how we can like make progress on this. So basically what we discussed in the last sub0 was, okay, what is like verifiable metadata, why we need that, how that affects like Ledger support and any kind of like air gap hardware wallet or any actually air gap wallet that we want to kind of like get support. And we did a demo. We are going to kind of like review that a bit today, and we're going to go through that again. So, I mean, just because maybe not everyone was like at that point, or they are not or not aware about like what this means. I'm going to go like very briefly. Later we can have like a session on questions and answers about this. But the main concept here is that the assumption is that you want like hardware wallets to provide you a clear signing, like information about what you're signing, and you have to work on the assumption that the host or the computer that is running the web wallet or the desktop wallet has been compromised. So the idea is that if you want to send, like, for example here, like some funds from one account to the other, the web wallet or the browser is going to be kind of like serializing that, but actually what is showing in the browser maybe is not actually what is being sent for signing. So there are like different opportunities where things can be compromised. One thing can be from the serialization of the transaction into the transaction blob, or also you could have like some problem during the communication channel or even the transmission of the packages. Typically what you have in hardware wallet devices is that you have to be able, or this is the advantage of hardware wallet devices, apart from like the secure element and keeping the key safe, is that you can also see what you are signing. But obviously, this has resulted like in some problems over time, because in the case of Polkadot, when we have like continuous like upgrades, and also there are like kind of parachains that they have different like type schemas, it's very difficult to do the parsing and showing that in a clear way. Obviously, the major challenge that we have here and has to be considered is that these hardware wallet devices, they have a very limited amount of memory. So we are talking about like 4 kilobytes of RAM, which is like 4,000 characters. So this means that the whole type system cannot really send to the device. And this has been a problem for a long time. We have these problems in other projects, like for example in Ethereum, when you have like ABIs, you don't have this situation. And this is kind of a nice improvement with verifiable metadata that is coming to Polkadot. I mean, Polkadot is the first one that has this kind of like advantage. So the idea is that initially, in Polkadot you have the metadata that has a kind of like full description of all the types that you have in that runtime. That applies not only for the relay chain, but also for the parachains. And you could eventually kind of like, based on the transaction blob that you have a kind of like a summary or like extract of the types that are relevant for that blob. But again, we have a situation where if you assume that the host that is connecting to the hardware wallet has been compromised, then those types could be kind of like misleading, and then you would be parsing something that is not actually what you are signing. So this has been a kind of ongoing problem. Like, you can improve not going for like blind signing, like signing just the hash of what you are like transmitting, but you still need to be able to trust the type schema and the schema of the data you're like deserializing. So the effort has been kind of like how to improve this. What we have been like kind of working on last year was this idea of like verifiable metadata. This has been, again, an effort about like from different teams. The main concept is that you have a Merkleized metadata, so we can like create a Merkle tree of the whole metadata, and then you can pass only the proofs of the types that are relevant for the transaction to be serialized. I mean, I can go a bit more detail, but bear with me. I want to give you more an update than the technicalities on this, but the main concept is that we are passing proofs of the types. The types are kind of like trusted now. once we sign the blob with the root of the Merkle tree of the types that we have received, and then the validation and the verification happens on that root 2 in the node. So even if you are light and the type schema or the types that you are receiving are not correct, the node will reject the transaction, and then what we are showing is always up to date. And in addition to this, if there are like upgrades on the runtime, or we are like dealing with different parachains, we are always receiving the types, so then there are no more needs for upgrades on the app that goes into the ledger device. This will like kind of like provide like multiple benefits. So one benefit is you can run the same app for any parachain as long as there are like these modifications in the runtime. There is only a single app that will run also for the relay chain. So we are like kind of like consolidating all this. Now, so the quick summary of what we had to do initially, it was like kind of communicated as, okay, there is a new ledger app, but actually there are like a lot of things that have to go along the process. So we have to do all this kind of like design on how to calculate the Merkle tree. Obviously the metadata is encoded in a scale, and there are like pieces that need to be kind of like removed, for example, documentation and things like that. So there has been a kind of discussion on a kind of like parallel type system that is kind of like re-encoding that metadata in a slightly different way. And this thing about like choosing the pieces of the type system that are relevant for each transaction means that we need to create a library for that. There is a part of proof generation, and there has been some discussions on libraries like where you need like TypeScript or WebAssembly for different wallets in the ecosystem, and the ledger app development. So in a way, like the situation where we are like right now is all the app. Actually, we show that the kind of like proof of concept and the complete work done back in sub0, but there is a lot of things that are a bit. I mean, we are trying to coordinate this as well as possible, but we still need that to be completed before it's available for everyone to use. So, like basically, the main step where that started, and we are still in that, is the formalization of this. So since the ecosystem has been changing and the fellowship started to take over, RFCs started to get like even more important. So back in October in 2023, we presented the first RFC. This was like done like together with Alcymologists, Zondax, and Parity. That RFC, later after some reviews and discussion, that resulted in that RFC being superseded, and there is a new RFC that was like, okay, there is a typo there, it was like 2024, this year. RFC 78 is a new RFC that we collaborated with Parity on building that. And right now started like it's under vote. The vote started on March 8th. And why is this RFC so important? The reason is that obviously in order to get the integration, we don't want to start the effort like before the RFC is like completed and clarified. Otherwise, it will like result in loops and rechecks and duplication of work. So now that the RFC is about to be approved by the fellowship, we have like a lot of things that are kind of like a continuation of this. So one thing is like wallet integrations. We have a working group with like Talisman, Subwallet, Nova, Wallet, and Parity to define like how the UI is going to be working. So to facilitate the migration and new users jumping into the new app. In that sense, there is something that has also been a problem in hardware wallet support for some time. Especially it was like highlighted a lot during the crowdloan days, where the different teams were not coordinated in the way that they were like choosing the derivation path. So that resulted in different teams having different addresses that were not like aligned. So after some work and discussion with other teams, we have like kind of like decided to see if we can like integrate and move everyone towards the same derivation path that Polkadot is using, even applicable for Kusama. So that means that we will provide another application that is a migration app that will allow everyone to come to the Polkadot derivation path. That will facilitate a lot of the situations that where some people that were like were participating in crowd loans with like parachains that didn't have like enough traction and they got like their funds locked. They will be able to recover the funds and they're going to be moving over. In that situation, in a way, for us was complicated and it hurt a bit our reputation, because some teams were just like forking the production apps that we were maintaining, and they were like giving those to their users. But in the end, it's like they were like leaving that in the middle, and that resulted in people believing that it was us that was like not maintaining the app. So this situation is going to kind of like improve a lot. So we are working on this migration path. There is also a situation where during the migration, we are aware that there are going to be kind of like situations, for example, where some people will have like funds locked, depending on the functionality of the parachain. They will need to kind of like maybe unstake or migrate. These are all challenges. They are not like related to our work, but are challenges that we are like kind of like trying to coordinate and work with the wallet, so they improve the user interface and the user experience. So we move to a kind of like much more kind of like stable situation. And there are other works on wallet integration being done in Ledger Live that will also have kind of like to adjust to this verifiable metadata message that needs to be attached to the blob to sign. There is another piece of work that is like kind of relevant and is also we are coordinating, but is out of our control completely, is the runtime upgrade. So basically, in order to have verifiable metadata, what we need to do is we need to get this Merkle tree root as part of the sign extension in the runtimes. And this is something that Basti and other people in Parity have been already working on, but we still need the runtime upgrade to happen. And obviously, because of all these changes, there have been not too many upgrades in the last few months, so we're kind of like waiting for this progression to happen. I imagine that initially will happen in West End, like Kusama and Polkadot. And we also recommend that every parachain that wants to use the generic app apply this kind of like a feature. So the sign extension will be required to use verifiable metadata. There is once the RFC is clear, this can also happen in parallel, but it's important to take into account that the process, the release process of a Ledger app involves like several audits in between. So first we do a lot of like an internal audit that we will have to run again once the RFC is approved, because I mean we believe the RFC is stable, but there could be surprises and we need to modify something. After that, there is an audit with an external auditor. We typically have like that's our normal process, and we go to a few external auditors that are recognized. And later there is this Ledger internal review and Ledger functional review, where it's not only checked that the security is fine, but also that the user experience is compliant with their practices. So after all this takes place, there is a follow-up work that we are going to be doing, and is that we are aware that the migration will not happen kind of like timely. Some users will have their hardware wallet or their devices like left in some drawer in their desk, and they will come up in 2025 saying, okay, now the app doesn't work, I'm using the legacy one. And so we are coordinating with other teams also to kind of like have a much more clear marketing and communication strategy. So we inform all the users that, okay, there is a new app and there are these conditions and how to do the migration and everything. So there are a lot of kind of like aspects that go beyond the just like development of the app itself and just the code that need to be taken into account, so the ecosystem does this transition properly, and then there is a single app that works for everyone in the ecosystem. Last but not least, there will be a point where we need to deprecate the legacy apps, and once an app is deprecated, it disappears from the app store, so we will need to kind of like coordinate this and also communicate so people do not get scared, because obviously they will be able to move, but there are always surprises. Like you try to do it and it doesn't work and you freak out. So this is a process that also is more on the communication side rather than the technical side. But as you can see, regardless of the demo that we did last year and that the app is already there and ready, there is a lot of process along the way that we need to kind of like be sure that they take place before everyone gets access to the app. Otherwise, we'll have a kind of like incorrect rollout of the new application. And in some cases, this it's depends on external factors that we don't have control over. But right now, I mean, something that we really want to kind of like ask everyone in the fellowship to pay attention to is that right now the RFC is finally being reviewed, and once we get that approved, we get started with the next steps. So just this is I put a big warning here because we wanted anyway to show a demo with Polkadot.js, and I'm going to invite like Carlo to do the demo, and so you also see where things are kind of like tangible. But the warning is because obviously, as I expressed, this is not just, okay, the code is ready, we can use it. There is a lot of things that need to go in between, and right now the RFC approval is the most critical one. So Carlo, if you want to join, I don't know if you need to.
Yeah.
Yeah.
Yeah, so mainly our idea of the demo was to show a simple transfer, because last year, as Juan pointed out, we just shown the workflow on the device. So we wanted to show as well the workflow on a regular wallet that everyone used at least once in life, that is Polkadot.js. So yeah, let me open everything for you. May we change the sorry? Duplicate, right? But I think I can move around, or? No. Okay. Yeah, it's fine like that, yeah. Yeah, so... so mainly, let's go for Polkadot.js. For this time, we want to use basically brand new chain that it's, yeah, if it wants to find it, let's see. But yeah, we are going to use for this demo Paseo, which is a new community-driven chain. Yeah, so Talisman wants the password. Not going to use Talisman today, soon. But yeah, basically, so Paseo is a new community-driven testnet that basically it's the same as Polkadot, but in a way that you can get your tokens and test around. So yeah, basically, yeah. So are we getting the camera or recording? The okay. But how are they? Is it fine? Yeah. So basically, I just onboarded 2 accounts as they are normally done. So you would just click from Ledger, choose the index you want. So as we have been doing for a long time, right? I'm going to name it test 3, for example, or test 2. And the idea is that the workflow is pretty similar. Now, yeah, I see my screen there. So yeah, the idea is that the workflow is pretty similar, and yeah, might we see the computer? Sorry for... but yeah, so yeah, let's just start with the send transaction thing. So I just send from this account to address 1, amount 50 pesos, and yeah, let's use keep alive checks. And if we click make transfer, sign and submit, yeah, now it's when we need the camera. Yeah, so could we zoom in a little bit more? Yeah, well, can we zoom in a little bit more? Okay. This is the maximum. Okay, yeah, whatever. So you're not seeing that, but I'm going to read it for you. So it just says chain Paseo. So this is the main change that it's going to happen in the user workflow. So you're actually going to see which chain are you signing for. And yeah, the first screen I'm seeing, it's chain Paseo. Amazing. Then I see the extrinsic that I am actually using, which is balances, transfer, keep alive. And I see that the destination is an ID, and I see the address already encoded with the SS58 format of Paseo. So that's the great thing. Then I see the value, pass, I also have the ticker 50.0, and yeah, I can approve it. And if we see in the right screen, so it will broadcast soon, and everything will happen. Yeah, so we effectively broadcasted everything, and we can see that now test one has 170 peseos. So the great thing about all of these is that with one single application, we will see actually which chain are we signing and getting everything encoded with the parameters of that specific chain. And this is going to be secured by the, what Juan explained of the Merkleization and basically verifiable metadata. So this was basically the demo. And I don't know if maybe there's any questions or?
I left some space for questions because maybe someone from the parachain teams have like interesting questions. So
yeah, maybe we can change to the other computer. It's fine.
Yeah. So I don't know if there are any open questions about the status or changes, or we are happy to go through that. Otherwise, of course, I mean, you can. Yep.
Is there any like rough timeline about when they?
Sorry, go ahead.
Is there any rough timeline about when this will be like finally released and be ready to use?
So, I mean, we don't have like a timeline that we have control over. I mean, from our perspective, I mean, in the sense of like what we are committed to do, we are kind of like ready. But I would say if things go well and the RFC is approved like very soon, I would say at least like 6 to 8 weeks because of the process of like auditing, approval, reviewing, and everything. So, I mean, in a very optimistic sense, I would say that that's the timeline that we can kind of like communicate at the moment. The only reason we have not made the application public yet, like for everyone to use, is because until there is no kind of like clarity on the RFC and the runtime kind of like upgrade, we don't want like the application to start like kind of being forked and to get like, but the application still has like been shared with Parity and other kind of like critical stakeholders. So like, for example, most of the wallets, they already have access to the app. What we are trying to be kind of careful is not to kind of like have a kind of like massive spread that is going to kind of like generate like confusion in the users.
Thank you.
Awesome. So next question.
For me, it was a timeline question mainly. But I just have one small question. So there's going to be a new app for the ledger. So it's going to be it's named Polkadot, or it's going to be named differently, or is this something that doesn't matter?
So at the moment, the plan is that it's going to be called Polkadot, and we are going to be communicating that you can use the Polkadot app to sign Kusama, statement, and every parachain. Yeah.
It will be okay.
But as Carlos showed in the demo, when you use the Polkadot app, depending on the transaction, it's going to tell you that. Also, I mean, I didn't go in details, but this is part of the RFC that is like public for everyone to read. It's not just the type system that we kind of like communicate, but we also communicate the token name and the number of decimals. There are other things that are not typically contained in the metadata, but that are also communicated and part of this Merkle tree.
Yeah, in a quick one, for the security reviews, are you planning to disclose or publish any of the results?
Yeah. This is not a problem. Yeah.
All right, we have the last question. Oh, sorry, 2 more. Okay, let's go ahead.
So we spoke about the benefits of like verifiable signing. You can see the chain and the extrinsic, but because this is one application that multiple different networks can use, I understand that you'll also be able to perform cross-chain tasks like participating in crowd loans and bridging funds between chains using XCM on your ledger device for the first time. That's correct, right?
Yeah, then the idea is that effectively, as we told, there's going to be a migration from different derivation path to everyone using the same. So actually, you would be able to use the same keeper on every chain. And the cool thing is that, it's going to be absolutely verified and secured by the runtime itself. So that's...
There is one thing that I would like to add, because I think it's fair to say this. This has been not just like Zondax working on this, but a collaboration also with alzhemologists. And this is not something that only benefits Ledger devices, but it will help also other hardware wallets or other teams, like for example the Campella wallet that Alcimolo is working on, and it's going to kind of like help anyone that needs to do some kind of like air gap verifiable signing where that was not possible before, especially affected by all the issues with like runtime upgrades that were like kind of affecting a lot of the people in the ecosystem.
Awesome. Let's take the last question.
So the legacy apps will be removed from Ledger Live at some point. Will they be available for very late adopters on your hub? So if somebody comes in 3 years from now,
Yeah.
would they be able to migrate?
The problem with this, and that's why the migration app appears, is that once this runtime upgrade that will happen on these steps on every chain, you won't be able to use the old app because there's a new sign extension which makes the payload of the extrinsic different, and it will not work. That's why the migration app comes to the stage, because it will make you be able to sign transactions with the old keepers, yes.
So in practical terms, for how long would people be able to migrate?
Yeah, there's no
No
specified
deadline?
there's no specified time frame for that.
As long as the migration app is there, it will be possible. And the migration app itself is actually the same app as the generic app, with the particularity that it can derive other paths, like legacy paths. So, I mean, the only reason we separated that is so we try to kind of like promote people to migrate and not to stay in the old like migration app for long.
Awesome.
thanks.
Awesome.